Back for some maths, we're still looking at fractions of amounts and bar models, although this time instead of unit fractions we've got non-unit fractions. Because previously we've had numerators of only 1, whereas now we've got 2, 2, 3, anything bigger than 1 means it's a non-unit fraction. So it's going to be a really similar method with the same 3 approaches, however there's just an extra step to just put in there as well, so it should be building on that learning from yesterday. So if we think about what a fraction looks like, so yesterday we were really good at understanding what a third was, so now it's just about taking that step further. So denominator is how many parts it's out of, the numerator is how many parts there are. So in this case it's out of 3, there's 3 altogether, but actually I've only had 2 of them, so if it's pizza it was cut into 3 slices and I've had 2 of them. And all we have to do is transfer that understanding into our bar model. So it's split into 3 equal pieces, and then I want 2 of them. So what I'm going to do is put an arrow underneath that reminds me I need to have 2 of them at the end. And then the rest of it's the same. So 18 goes at the top, and then it's just about sharing that amount in equally. So I'm going to use a tally to start with. I'm going to count up to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Stop there because I'm at my target number. So in each piece I've got 5 and the next ones I've got 6. Before I move any further I'm going to double check by adding it up 3 times, or you could multiply it by 3. 6, 12, 18. Yeah, so I've checked that I've got back to that. But I don't just want 1/3, I want 2/3, so I want 2 lots of 6. So I'm just going to add them up, which equals 12. So now I can confidently say that 2/3 of 18 equals 12, because I've checked that it was 6, and I know that 6 and 6 is 12, so I've added that up. I could add the last third on as well to make sure I get back to 18, that would be a good double check. So let's move on to our next one. The same method again, but this time the fractions changed. So I won't do it as a pictorial representation because I know it does. So I'm going to split it into 4 pieces. And similarly, it just wants 2 pieces. I could have any 2, but I always like picking the front 2. It just makes sense. The amount I'm going to put at the top, as normal, is 48. And this time I'm going to think about sharing out with place value counters. So before I put any numbers in, I always try a number. So obviously I've only got 48, so 100 as a place value counter would be too big. So I'm going to use 10s. 10, 20, 30, 40. That works. So I'm going to put 10 in. 10, 20, 30, 40. And I'm going to carry on counting, but I can't put 10s in anymore because I'm really close to my answer. So I'm going to put my 1s in. 40, 41, 42, 43, 44, 45, 46, 47, 48. I'm at my target. So now all I need to do is add up one piece. So I've got 10, 11, 12. Going to do my double check. 12, 24, 36, 48. You could obviously add it up using a formal written method or using the grid method. But now again, I want 2 quarters, not 1/4. So I'm going to add 12 twice because I need 2 of them, which equals 24. Now, did anyone notice that 2 quarters looks like this? However, I mean, it's a pretty bad drawing because they should be equal, but it's also the same as a half. And if we think about, well, half of 48, half of 40 is 20, and half of 8 is 4. So always think about how we can check for sensible answers and how we can double check our own work. So the last question we're going to have a go at, got that lovely sun, is into fifths. So we have got 3/5 of 40. So what we're going to do is we're going to share it equally into 5 pieces. 1, 2, 3, 4, and of course the 5th one on the end. So now We're not going to use place value counters, we're just going to use sensible numbers. Now, of course, I could try 10. It's always a good place to start. 10, 20, 30, 40, 50. It's close, but it doesn't work. Let's put our 40 at the top so we know our target number. And of course, this time we're having 3/5. So I need to show 3 arrows because I'm going to be adding up 3 pieces. So 10 didn't work, so I'll try 5. Remember, before I put it in, I always try the number. 5, 10, 15, 20, 25. Now that works. And remember, it's always numbers that you're comfortable to count up in. So 5, 10, 15, 20, 25. Now all I'm going to do now is continue in the form of a tally, because I know I'm quite close. So 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. We're there. So now all I need to do is add up one piece. So I've got 5, 6, 7, 8. And before I go any further, I'm going to double check. We're good at our 8 times table. So 8, 16, 24, 32, 40. Yes, it works. So therefore I can have 3 of them. And then I'm going to add them together again. 8, 16, 24. So then I've checked my own working out. And of course, that's 3/5. I could add another 8 and another 8 to check that I'm right. But because we did that first counting, I'm quite certain. So there we are. We've looked at fractions of amounts with non-unit fractions, where we've got numerators that are bigger than 1. And we've looked at some different ways. So we've got just using tallies. We've got place value counters. And here we've got a mixture actually, which I quite like. We've got sensible numbers. And then we've also got a tally when we were close to that target number. And it just meant we didn't have to do any of that subtracting or that adding at the side. But of course, you're more than welcome to do that. It's about choosing a method that's right for you. Whether it's a mix and match, it's just about sharing it equally and then being able to double check it before you move on with adding up the correct amount according to the numerator. So now that you've seen me do it, I've got some practice for you. 3 questions and a challenge if you so wish. We have got 2/4 of 24. We've got the same number again, but this time I want 2/3. 3/4 of 32. And 4/5 of 75. Be really careful when drawing your bar models, and you can see that with mine they did start to get a little bit cramped, so maybe draw them big enough that you can put lots of numbers in so it's not squished together, because the last thing you want to do is make a mistake when you're running out of room and you're squeezing tally charts into your boxes. So pause the video and have a go at those questions, and we'll look at some answers in a moment. Okay, let's go through some answers. So we needed 2/4. So 1/4 should have been 6. 2 of them should have been 12. And again, did anyone spot that that was a half? So we could have also double checked by half in our answer. So we've got 12. 2/3 of 24, same number but different fraction. 1/3 would have been 8. So therefore 2/3 is 16. 3/4 of 32. 1/4 again was 8. So similar numbers, but we've got different fractions and a different starting amount. And then of course 3 of them, 8, 16, 24. And that's nice because we're good at our 8 times table. And then finally for our challenge, 4/5 of 75. 1/5 was 15 and you had to add it up 4 times, so you needed some patience. And we should have had 60 as our answer. So you've done some practice, hopefully you got on okay with those. Have a go at making up some fractions of your own. Remember, I like the numerators 2 and 4 if you're looking at even numbers. But there'll also be some on the website for you to practice if you're not sure at making up your own. But it's all about drawing those bar models and sharing equally and then adding up the pieces according to the different numerators.